Hello. So today we move to another exercise. We are moving towards the end of the exercises that has to do with factors. I think it will only take another 2 to 3 classes before we finish factors. Then after which we move to multiples. So here is another exercise that has to do with factor, but in this case it's what? Highest common factors. In the last class we talked about common factors, meaning the factors that are common between two or more numbers. Now we want to talk about highest common factors. Highest common factors. So let's have this. We want to find the highest common factors existing in these prime factors. These are prime factors numbers. So they said find the instruction says find the HCF of the following. Leave the answers in prime factors. We now understand what a prime factor is. Good. So in doing that, we said the first one, 2 times 3 times 3 times 5. This is a prime factors, multiples of prime factors, the product of prime factors. The same thing applies here. 2 times 2 times 3 times 3, then times 3. The same thing, the last one there, 3 times 3 times 5 times 7. And we have to find the highest common factor. The highest common factor there. These numbers are expressed as a product of their prime factors. This is a number. So if you want to get a single number, you just multiply everything. The same thing, you multiply 2 times 3 times 3 times 5, you get a single number. The same thing with this and that. So how do we find the HCF of this kind of arrangement? We pick the number, the prime factor that is common to all of the three expressions. 2, no 2 here, meaning 2 is not common to all of the three expressions. 3 is here, then 3 is also here, so we join them together, we write them as 1, 3. The same thing applies here. 3 still exists, it still exists here, we write it down. So here now we have only 2 and 5. Here we have 2, 2, and then the 3. Here no 3 existed here, meaning 3 is no longer common. It's no longer a common factor as we have here. So in that case, the highest common factors of these three expressions is 3 times 3, and that gives us 9. So the big part of it, we have 2 times 3 times 3 times 5 times 7. Then we have 3 times 5 times 5 times 7 times 7. Then the last one, 2 times 2 times 3 times 5 times 5 times 7. Then the HCF, the highest common factor. As we have done there, we do the same. 2 existed here, no 2 here, so 2 is not common to all the three factors. So what do we do? Do we have 3 in all? Yes, 3 is here, 3 also existed here, so we write out the 3. Also 5 existed here, 5 existed there, we have what? 5. 3, no 3 existed here, no 3 is here, 3 is not existing again here, no 3 here, though 3 still, meaning 3 is no longer a common factors there. So what do we have there? Here we have 7. We also have 7 there, so we pick the 7. So when you look at the remaining numbers that are there, you see that those main numbers are not common to all of the three expressions again, meaning we have written out all the common factors. So the highest will now be the multiples of all this. So 3 times 5 will give you 15. Then 15 times 7 will give you what? 7 times 5, that is 35. We keep 3. 7 times 1, 7 plus 3, we have 10. So 3 times 5 times 7 will give you 1 over, which is the highest common factor here. Thank you for listening. Then we now move to another number, still under the same exercise, 3f. Thank you.